Hey, Mr. D, how you doing?
I can't complain. How about yourself, Mr. Bergman?
I'm doing good. So, first video of chemistry. Tell us a little bit about yourself.
I used to play basketball and soccer in college, and I was okay.
So you were like a stud.
No, no. If stud's up here, I was but right here. I was average. I was okay. I could play.
All right. Well, you've been playing college ball. That's pretty cool, though.
You had some sports background as well, right?
Yeah. I was a swimmer and I played water polo, and I was a good high school swimmer. That's as far as I could say. I made the state team. I was all state in water polo, but that really wasn't like really good, because to be really good, you have to actually be tall in swimming. I don't know if you know that, but you have to be tall, and as you know, I'm not tall. I'm short. So, yeah, my chances of collegiate swimming went out the door.
Fair enough. Fair enough.
Hey guys, today what we want to do is we want to learn about matter. The topic today is matter. Matters. So, matter. Mr. D, what's matter? What's the definition of matter?
So that's a really good one, because matter, we say, is anything that occupies space and has mass, which begs a really, really great question. Is there anything around us that's not made up of matter?
So that's a good question. Let's talk about some things that are matter. What are some examples of matter?
Well, do you want to talk about solid matter? I mean, the reality is, anyone, as you're looking at the video at home, you could point to anything in your room and go, that's made up of matter.
Okay, so like what? Give me an example. Just something that you might find in a typical teenager room.
A lamp, I would guess
A lamp.
a TV. Phone. How about a phone? I mean, everyone has a phone, right?
So you're talking those, if you think about those, in my mind, those are all solids. Can something that's like in a different state be matter?
Never leave home without this, especially in Houston, Texas, right?
Oh, so water. So you're going to say liquids like water would be any liquid would be matter? Any liquid?
Any liquid. As long
Any
as
liquid. Now I remember back like when I was in middle school, or maybe students, you remember this when you were in middle school, but there was these gases. But gases, you say they take up space and they have mass, but gases don't have any mass, so they can't be matter, can they?
That's a really great question. So if you take a look at your typical balloon, right?
Yeah.
You all agree that it takes up space, right? Because it
Yeah.
occupies space.
Blow it up and stuff like that. But it doesn't weigh anything.
Yeah, if we took that balloon and put it on our bathroom scale, we'd say, oh, no, it doesn't have any mass. But if you put it on a really, really sensitive balance, you'd actually realize that those particles of gas, they actually occupy mass. So even though it's really, really tiny, it still occupies mass.
All right, so gases are mass too. So all things that we can sort of see, touch, and even things that we kind of can't really see or touch, they're matter.
Everything is made up of matter. There's not anything you can point to that isn't made up of matter, which is kind of cool.
But wait, in the world of science, there's sort of something that isn't matter that's still like something that matters. What would that be?
Are you talking about light? Are you getting
Yeah.
crazy on this now?
Yeah, because when we talk about we're talking about matter, but just the opposite. From a scientific perspective, the thing that isn't matter is energy.
Yeah.
And that could, like you mentioned, it takes the form of light, things like that, so light and stuff like that. And that is something that scientists are going to study. We're going to learn about energy in the course of the year, but we're just focused on the matter right now. Make sense? So when we talk about matter, matter can have some properties. Let's take a look at a video where we look at some of the properties of matter. Matter has properties. For example, these two objects obviously have different volumes because they're like different shapes.
They occupy different space.
They can also have different masses. If I put them on a scale, they'd have a different mass. If I threw them, they would have a particular speed.
Clearly.
Properties. And there's lots of different properties. We mentioned some: density, speed, mass, etc., etc. Mr. D, as we're talking about these different properties that we have over here, is there a way to organize them?
There's two categories, and fortunately for all of you watching, we have a video to show you all.
Well, I think we should go to the video.
I think we should.
All right, I have my assistant here with me, and the photographer as well. So we're going to talk about extensive and intensive physical properties, and here's the deal. extensive physical properties, it matters how much you have. So let's say I wanted to take your mass. What I could do probably is just take a machete, because in the olden days we could do such thing, and just chop off your hand
Ow!
and put this on a scale, right? Because that would give you your entire mass. Or am I talking crazy?
You're crazy, man, because my hand, but that's the mass of my hand, not me.
Clearly. So when we talk about mass, the amount of you, the amount of matter you have actually makes a difference, right?
Yeah.
So if we
You're
put
not
this
taking
apart-
a part of me out.
Same
Just
thing.
saying.
Same thing. If I like, none of you would be like, hey, okay, let's just chop off your finger, put on a scale, and that gives you your mass. That'd be
No.
a terrible way of doing it.
Yeah.
Similarly, when we take a look at something like a piece of paper, what color is this?
White.
White.
Blanc.
I'm going to do a magic trick here. You watch. It's going to be fast. Ready? Different color.
No, it's still white.
It's still white. Now I could do this again because we spare no expense when we're trying to teach like this.
Yes.
Watch this. Blue or turquoise color?
Blue.
Red.
Still blue.
You saw through my facade. That means that does the amount of matter when we talk about color?
Color, no, because
No.
color doesn't change. So there's two different kinds. So intensive is what?
Means that it doesn't matter how much you have. So your shirt is red whether I take a piece of it
Yeah.
or the entire amount.
But extensive.
Extensive, the amount of you matter. So let's think of some characteristics
So
that might be
intensive
extensive.
is like measured stuff.
Yeah, so like your height,
Yeah, well, height, weight, mass, stuff
volume, the amount of space you take up.
Got it.
And things like intensive would be like
like
color.
that. Color. What else could?
How about this boiling point? Like if I took a cup of water, let's say we take this flask here and I fill it with water, imaginary water.
Boil.
right?
It doesn't change depending on how much I have.
Let's say I take a thimbleful, because that's an
It still
international.
boils at the same temperature.
Still boils at 100 degrees Celsius,
Yeah,
right?
yeah.
So things like that, where the amount doesn't matter, we call those intensive physical properties, and where the amount of matter matters, it's kind of a redundant thing.
Matter matters.
Matter matters. We call those extensive.
All right, Mr. D, we've got the intensive and extensive. Can you explain what they are? What should our students put in their notes? So what's the definition of an intensive property?
Intensive property is where the amount of matter doesn't matter. Kind of a weird way to say it, but amount of matter doesn't matter.
And extensive?
The exact opposite. The amount of matter matters.
Now, we do have these in the videos, but let's kind of put these out. What are some examples of some intensive properties?
Well, we've talked about color, boiling point,
Color.
melting point, density. These are all examples that it doesn't matter how much stuff you have, these don't change.
Oh, good. Okay. And then extensive?
Yeah, extensive are the exact opposite, where the amount of matter does matter. So things like length, height, like we did in the video, we can't take Mr. Bergman's mass by just chopping off his hand. The amount of him makes a difference. So anything where the amount actually matters, that we consider to be an extensive physical property.
Well, folks, the last thing that we want to talk about today is that when we talk about matter, there are actually some states of matter. And we've already talked about these, right? We've got solids, liquids, and gases. So, Mr. D, what's the difference between a solid, liquid, and gas? I know there's like a definition-y thing. What's up with that?
Yeah, let's get some hard definitions in here, and then we'll just describe them. Yeah, so solid has something that has definite shape and definite volume.
Okay. Liquid?
Liquid has no definite shape, but definite volume. And a gas, if you can follow the trend here, no definite shape, no definite volume.
And I'm saying no shape. It really is definite shape. Okay.
No, if you want to look around you right now, I mean, just in front of you, tap the desk in front of you. When you tap the desk in front of you, that desk has not, it's solid, right? It does not change its shape unless you're
Its shape didn't change. No.
episode. Definite shape and the amount of space it occupies, which is another word for volume, right?
Volume, yeah. Mm-hmm.
That didn't change as well. But if you take a look at, let's say, water,
I guess you pour it and you move it around, the liquid changes its shape because of the shape of the container.
right, now, if you took a look at this right now and I changed the shape, if I were to pour this all out on my computer, which would be a really bad...
It'd be flat. It'd all be all flat.
It would be
So,
flat, but the amount of space it's occupying would not be any different.
yeah, fair enough. Okay, but how would that apply with a gas? Actually, I've got an example. This morning I had to put some air in my tire, which you'll learn about the tire problem of Mr. Bergman's car a little bit later. And in that tire problem, I had to add more gas, and what happened is the shape of the gas took up different spaces because the tire got more inflated. And it took up more volume, and it had no definite shape.
We'll learn this later when we talk about gases, but a gas will expand to fill whatever container you put it in.
Yep.
So,
Yeah, the container was my container was the tires of my vehicle. Now let's talk now about how these work from a molecular level. So here's something that's really weird. You may not believe me, but all matter is moving all the time. Moving. Now, Mr. D, you're sitting at your computer table. Now, does it look like your table is moving?
not now, unfortunately.
Yeah, it doesn't look like it's actually moving, but from a molecular level, the difference between a solid, liquid, and a gas has to do with how they're moving and vibrating. So let's take a look at this image over here. And as we look at this image, or this animated GIF, I guess you would call it, you can see what's happening is that the solids are vibrating. They're moving back and forth and back and forth. The liquids, you can see them moving a little bit more severely, and then the gases, they're flying all over the place. So when you zoom in to the little tiny things we call elements or atoms, we'll get there a little bit later, we'll discover that solids vibrate a little bit, liquids more, gases a lot. Any thoughts on that?
No, it's exactly that. Think of it as how close they're dancing to each other. Solids are locked in, liquids are kind of, and then gases are all over.
And one last thing to talk about that, as we're still looking at this image here, is that the reason a solid is a solid versus a liquid, a gas, has to do with the strength of the bonds that holds them together. So if it's a solid, it's going to have stronger bonds, which causes the atoms to be closer. Liquids, if you will, medium strength bonds, for lack of a better term, and gases, they're weak bonds, and they don't connect. And we'll learn all about this later when we talk about bonding and all the connections of atoms, but understand that solids, liquids, and gases are part of matter.
True story.
So hey guys, Houston, we don't have a problem. We've got this.